Okay, welcome back to our flipped lessons on quadratics. Today what we're going to be looking at is a process called completing the square. What this is a method for taking a quadratic that's in general form, ax squared plus bx plus c, and transforming it to vertex form. Why would I want to do that? Well, when I have it in vertex form, it makes it very easy to identify the vertex, which is important when we're looking at contextual problems, when this is modeling some sort of real-life situation. That vertex represents a maximum or a minimum value for a certain function. So, how do I do that? Before we get into actual completing the square, we're going to look at a special trinomial, x squared minus 6x plus 9. This is something we call a trinomial, perfect square trinomial. If you recall back when we learned how to factor basics at the beginning of the term, a trinomial factors into two binomials. Let's see, first terms would have to be x. And then, let's see, how did we get the second terms? We looked at two numbers that multiplied to give c, 9, that added up to b, negative 6. Well, in this case, that's minus 3 and minus 3. Now this I can rewrite, since these are identical, I can write this as y equal x minus 3 squared. Now, what I've got is vertex form. K, the number that's added to the outside, is just 0. A, in this case, is 1, and H is 3. So my vertex is at 3, 0. Now, this one was really nice. It factored, just simply by factoring, we could put it into vertex form. But that's not always the case. Why did this work out so well? Well, for this to factor into a binomial square, what has to be true is the last number, 9, that's 1/2 of b, 1/2 of the second term squared. Negative 6 over 2 squared, or negative 3 squared. So for a trinomial to factor into a binomial square, what has to be true is c has to be equal to the negative well, not really negative, b, 1/2 of b squared, excuse me. So, if we've got a situation where, say we've got x squared, let's say plus 8x plus 1. Is this going to factor like this one over here? Well, no, it's not. So we've got to go find a way to create something that will meet that criteria. So the way we go about this is, first thing we do is we kick out c. And we're just going to work with what is left here. Now, we're going to create a trinomial by adding a term in here. Ignore that plus 1. We're going to create a trinomial over here. And what do I want to see there? In order for it to factor like it did here, I've got to have a number here that's 1/2 of b squared. So I'm going to, let's see, I want to take 1/2 of b and square it. What is b? b is 8. So that's 1/2 of 8, or 4, squared. Now again, how did I get that? I want to add a term here that is going to be 1/2 of b, in this case 8, squared. So I took 1/2 of b, in this case 1/2 of 8, and I might even go in here and just put the 4 right there, or the 8 right there, excuse me, which is 4 and squared. That's going to be equal to 16. So that is what I add here. And I know what you're thinking here is, Mr. Clark, that's illegal. I can't just add a number to this equation because that makes it unbalanced. Well, to keep my equation balanced, to keep it true, out here I'm going to subtract 16. Now if I add 16 and subtract 16, what have I in effect added? What's the net that I added? 0. I can add 0. So what I have here is y equal x squared plus 8x plus 16. Keep that trinomial together. And out here I've got minus 15. You with me? Good. Now, looking at this trinomial right here, now I've created a perfect square trinomial. This will factor into two binomials. First terms will have to be x. Factors of the last that add up to the second, that's going to be plus 4 and plus 4. I'm minus 15, he stays out there. And so what I've got now is x plus 4 squared minus 15. What is my vertex? Well, x, it's in vertex form. A is 1. I got x minus h. Well, x plus 4 is the same as x minus a negative 4. Or it's always just the opposite of the sign you see there, like we talked about. So my vertex is negative 4, negative 16. Well, what do you think? Probably need to see another one, don't we? Okay. Let's see what you can do with this one. Now, before you start on this, I'm going to ask you to pause the video and see what you can do with it. Some problems come in here in the form of fractions. See if you can deal with them. Okay, so pause the video and work. Well, you're back. Okay, let's see how you did. Let's see. First thing I want to do, does this thing is a perfect square trinomial? Gosh darn it, no. Okay, so first thing I'm going to do is kick out C. So I'm going to kick out minus 1. And I'm going to work with what is left. Now, this gets a little bit ugly. I want to add a term in here so that it is 1/2 of b squared. That'll help me create my perfect square trinomial. So I'm going to take 1/2 of 9, and I could make that a decimal, but I like fractions. Remember, fractions are your friends. And I'm going to square it. So 9/2 squared is 81/4. Told you it got a little ugly, didn't I? So that is what I'm going to add inside. But to keep my equation balanced, I'm going to subtract it out here. Now, here's where it gets a little bit tricky with the factoring when you got fractions. But I think I can show you a shortcut. Because normally we'd say, okay, factors into two binomials. And first terms are x. And then we say factors of this that add to this. Well, here's the trick. it's always going to be the square root of that last term. It's always going to be that 9/2. Well, not always 9/2, but it's always going to be 1/2 of b. So it's going to be, I'm going to have 9/2 here, 9/2 here, and they'll have to be positive. Now here, through the miracle of combining fractions, let's see, that's -4/4. That'll be -85/4. So this becomes my binomial square, x plus 9/2 squared minus 85/4. Anyone get that? All of you. Terrific. So looking at this, can we take a little bit more of a shortcut? Once I create my perfect square trinomial, it'll always factor into, I'll have the square root of the first term. It'll be the square root of the last term. Keep the sign of the middle squared. So we can actually skip this factoring step because it'll always factor like that. All right? Kind of challenging, I know. But things get even uglier. Because what if I have a trinomial that looks like this? I don't know why I keep doing -1. It doesn't really matter. How is this different than our previous problems? That's right. A in this case is 2. Before it's been 1. Well, looking at vertex form, A is factored out in front of that binomial square, isn't it? So, what I'm going to do, I'm going to kick that -1 out, like I did before. But now I want to have A factored out. So I'm going to factor it out of just this binomial. So I'm going to pull a 2 out of there. -1 on the outside. Notice that I left a little room right here. So I left some, the reason I did that is so I can add a term there to create my perfect square trinomial. Now I'm going to go through the process here. What is B? B is 2. So I'm going to add a term that's going to be 1/2 of that squared. And this is a little bit complicated, so I'll go over here and write it out. 1/2 of 2 is 1, and 1 squared is 1. So that's what I'm going to introduce inside. Now, what should I introduce out here so that I keep my equation balanced? Introduce a +1 here. So what do I introduce out here? -1? Wrong. Because what I actually introduced, if I multiply this back through, I get 2x squared plus 4x plus 2. So what I really introduced here was a 2, a +2. So to keep my equation balanced, I've got to introduce its opposite out here, a -2. Okay? So whenever I have to, A is not 1, I've got to factor that out. And when I complete my perfect square trinomial, I've got to remember what I really introduced was A times that, 2 times 1. And I've got to introduce its opposite. I really introduced a +2. I've got to introduce a -2. Now, square root of the first, square root of the last, keep the sign of the middle, squared. And out here, Let's see what I got here. I've got a -3. So now I can identify what is my vertex. -1, -3. Okay, now, I know this is a tough little procedure. We're going to find out tomorrow. There's a shortcut we can take to get to the vertex. So you're saying, why, Mr. Clark, do you put us through this heinous process if it's really not necessary? Well, this process is something that will pop up later in pre-calculus and calculus. It's a process that you need to know how to do, completing the square. Okay? So, why are we learning it? Because it's good for you. But yeah, it is a very handy thing later on, you'll find. I would like for you to try a couple problems for tomorrow. Try not to make them too bad, at least. At least one of them not too bad. This one, let's make it kind of ugly. Ooh, that's an ugly one. Now, give it your best shot. Tomorrow we will practice this, but I want to see what you can do with these. Give that to me. And we will learn that shortcut tomorrow, promise. So until then, this is Mr. Clark signing off.